Okay, Jill,
Okay.
tell us about larger scale SETI and how one builds its their own facility and how hard it is to manage it afterwards, or how hard it is to find the money to operate it afterwards.
Can I grab this? So I hooked that up to my Mac. Can we get it switched over? Thanks, Tony. All right. Sorry. Why is it you can never, what do you want? Probably 1024 by 1028.
That looks better. I see everything you're saying.
Okay. I don't see it, confirm it.
It's underneath.
Oh, thank you.
Now confirm.
Sorry, I was having too much fun having breakfast with David Taylor this morning. I didn't come over and put this on stick. All right, are we here? No.
Yes, I think
Yes,
so.
you are.
Oh, all right.
That's it.
Thank you. Yay! All right, so we've already made this statement that after 50 years of searching, we've done the equivalent of asking, are there any fish in the ocean? And our experiment has been to dip 1 8-ounce glass in the ocean. That experiment could work. The smallest fish is about 1 millimeter in size. Your eye could see it. And there are a number of fish species that would have fit in your glass. So that is an experiment that could have worked. The fact that it has not yet worked, I think we're at the point where, having dipped 1 glass of water out of the ocean and not found fish, I don't think we're at the point of deciding there are no fish in the ocean. I think we've got lots of things to do, as Andrew Simeon has already said. And the question is how we manage to do it. What's the right strategy? So we are building bigger and better glasses for radio searches. These are pictures of the Allen Telescope Array. And we today have 42 dishes, are trying to grow this to 350 to be a world-class telescope like the GBT out there. So it's good, but it will get even better if we can transform the Hat Creek Valley in Northern California to look like this. Hello there. Yeah, okay. So the Allen Telescope Array 350. This is a telescope that came out of SETI 2020, our look at the turn of the century about what we should do for the next 2 decades for SETI. One of our brilliant ideas for sustaining SETI, for providing the facility that Paul says is necessary, is that we would make SETI part of mainstream radio astronomy. We built this telescope to do SETI and radio astronomy at the same time. Right? We built it in a way that we could do multiple concurrent science projects. And this was pretty innovative. It doesn't happen other places. Why can we do this? Because of the large number of small dishes. Right? Our neighbor galaxy, right? The moon to scale, 1/2 degree across, Andromeda's 2.5 degrees across. That's, whoops, hasn't come up yet. That's Arecibo's field of view. That's the alpha field of view. That's what you get with a 6-meter telescope at 1 gigahertz. We've built back-end digital equipment. This is a Moore's Law telescope. Andrew's already mentioned that. We are data inundated. We're flooded with data at the moment. The midlife of this telescope, it's going to be well matched to the data rate. At its end, it's going to be data starved. But we've built the telescope so all the analog goods are there, and what we do is make the telescope better by making the back-end computational capability grow. So we can make a radio image of that galaxy in one pointing, many pixels, wide-angle radio camera, snapshot mode, and we can phase up and individually select pixels out of that large field of view. At the same time, that allows us to do point source science, one of which is SETI. So there's M31. There's the radio image of M31 made at hydrogen frequency. And in that field of view that maps that galaxy, we've got dozens and dozens of targeted searches, targeted stars that we can look at simultaneously with making that map by using a beamformer. There are also rogue planets out there, and maybe in fact intelligent technological civilizations are not associated with stars. And so what we are doing is a survey of 20 square degrees along the Milky Way plane towards the center, along which lines of sight there are somewhere between 4 and 10 billion stars. We don't know where they are. And, but this is the one area direction on the sky where you have the highest density of potential targets. And so we are systematically searching that region 3 beams at a time. If indeed a transmitter is at the distance of the galactic center, it would have to be 20,000 times as strong as the Arecibo transmitter in order for us to find it. But this is a search for advanced technologies and their beacons. And we have been pursuing at the Allen Telescope Array a number of different search strategies we have available to us, 1 to 10 gigahertz. So we are trying to expand the traditional search frequencies that have been done in the past. And we've had various strategies, and here's kind of, as of July, how well we're doing on some of these strategies. There's just an enormous opportunity to do SETI in many different ways at the Allen Telescope Array while we're doing radio astronomy. We thought that had to be such a winner in terms of sustainable strategy. We build a telescope that can do SETI and radio astronomy at the same time, and we would find funding from the traditional astronomical sources. It hasn't really worked. Tom's mentioned the Decadal Review. The National Science Foundation has not found either the willingness or the opportunity to fund this telescope out of the university radio observatories program. All right, so here's another way that we might sustain the community, which is to change what we're doing, to stop doing SETI all by ourselves as a small group of isolated researchers and bring the world in. Taking advantage of the popularity and the name brand of SETI to solicit donations of equipment. That has happened. We have the Allen Telescope Array 42 dishes. We have now gotten substantial donations, as Dan's group does, from industry. And we're at the very first moment in at least our SETI history where we can get away from custom-built hardware and take advantage of what industry is giving us in terms of commodity servers, which are now for the first time fast enough to do our real-time searches. So we've gotten hardware that's on the telescope. We've gotten a donation of cloud web services, and we are trying to reach out to the open source development community. We've actually published our code as open source and are inviting people to take it and do something else with it to help us make it better. We're also pointing at the, and we've gotten donations of services to go along with this. We're also pointing at the student and DSP communities, saying we've got lots of data in the cloud. We've got compute resources in the cloud for you. Come help us build algorithms to search for signals that we haven't been able to look for yet, these complex wideband signals that we're now having the computing capability to deal with. And lastly, we're trying to reach out to the rest of the world and develop a real-time citizen science program where people can use their eyeballs, their brains, and maybe even their ears to help us find anomalies in the data that eventually will be able to feed back real time, or within 4 minutes real time, and perhaps move the telescope to follow up on signals that we would have missed with everything else we're doing. So we're trying to take SETI, in the words of the open source community, out of the cathedral and into the bazaar, and to benefit from the creativity and the energy of all those smart people out there who are interested in SETI but don't work for the SETI Institute.
Jill, who was that woman that you highlighted?
Oh, Denise Cooper, she's the guru of open source. She's now the Chief Technology Officer for Wikimedia Foundation, and she has been our guide to how to make an open source project. So we are actually letting go a bit. We're thinking about letting the world help us do the next SETI project as opposed to us saying what that will be. It's a bit scary, and you get strange things as a result. We have this wonderful video that our students made that we didn't have anything to do with. So is that the model for sustainable SETI? Or perhaps this is the model, right? And Tom alluded to this. SETI is in fact a way of finding habitable worlds by detecting the technologies of the inhabitants of those worlds. SETI absolutely naturally fits under the umbrella of astrobiology. Should we be looking again to this getting within the NASA community support for SETI under this umbrella? Is that the sustainable model for the future? So we've tried a bunch of things. We're still trying new things. Some of them haven't worked out as well as we had expected. But we are trying, and I don't have any more suggestions about other things to do than what I've presented. Thank you.